Okay, from current slide. First, the math team, if you're interested, is meeting every Monday afternoon at 3 o'clock on the Birmingham West Campus, the Science Building, which is the C Hall, room C100. Mr. Rassi is the coach, and they're having a good time. A student in my morning class is in it, so they're really having a lot of fun, and he's learning a lot of math. And then they meet again on Fridays at noon. And so if any of you are interested, please consider going and participating. I've announced to you before about the tutoring schedule, on both campuses. I highly encourage you to take advantage of it, and maybe in the future, once you got a few A's in math courses under your belt, A's or B's, you can consider tutoring. They would love to have you. They pay fairly reasonably well, about minimum wage or so, maybe even above that, and it fits your schedule. Okay? Now, one other announcement. Seems like forever since I was on campus on a Friday. Actually, 2 Fridays ago I was, but then before that, it was several Fridays I wasn't. Again, this Friday, I'm not going to be on campus, at least in the morning, because I have a doctor's appointment in the morning at Kirkland Clinic, and depending on what time that gets out, I may go to campus afterwards or not. It just if it's really late, I probably won't go. But if it ends early enough, I'll probably try to get there. But I won't be there first thing in the morning. And I don't know how long it's going to stack up as my annual fiscal. I don't remember that it takes all that long, but it does have a bit of several pieces to it. So, all right. Any questions on anything we've done so far? Okay, we had started chapter 13 last time. And this is. I can't find it. Amaya, right? Okay, we had started chapter 13 last time, but we still have our test coming up on chapter 11, okay? And that, I think y'all decided you wanted on Wednesday, right? So Wednesday we'll be having that. That means please get your quizzes in today, tomorrow, or no later than Wednesday, because you can't take your test until you've done the quiz. So if you can get it into me sooner rather than later, I can get it graded. You can see what you may have missed, so you don't make the same mistake again on the test. And those who, I think 4 people turned it in last week, and those are graded if you want to see it. I can't return them to you because not all of them will come in, but you can certainly see what you missed, and so you can know what to correct for the test coming up Wednesday. Any questions on that? All right. And no questions anywhere then. Okay, we were on page 853, example 6. And it seems like we had done the first one, subtracting polynomials, the A part. And we were ready to do the B part, and that's when we ran out of time. And it may be that they don't have a B part. Yeah, they must on the slide, because they wouldn't have an A if they didn't. I just can't get it to advance. Okay? And there's Courtney, right? Yeah. Anyone else come in since I called roll? Okay. All right, here's the B part. No questions before we move forward. All right, now, so we're doing the ones on the slides because they're printed here, but the ones in the book are similar. Please do those, okay? They've got all the steps there, so please go through those as well. So here we say, all right, the verbiage. subtract this from that. What do we mean by that? Where do we start? Say again? Okay, and which do you write where?
It would be
the one to the right first, because you're subtracting this from that. So you write that first. That's what you're starting with, subtracting this from that. So you write this as, whoops, let me get my pen okay. 7y cubed plus 8 minus, open parentheses, y cubed. Oh, okay. Are you subtracting as you go?
Yeah.
You could. I'm putting it in parentheses. Well, that's how I would do it too, but just to get the feet wet with it, let's do this. All right. So you don't have to put the first one in parentheses. All you're going to do is remove the parentheses. The second one, though, if you're writing it down the way it was written, be sure you put it in parentheses, because the next step is what? Distribute the minus sign across the parentheses. So that would become negative y cubed minus 4y squared plus 2. Okay? And then we do what? Combine like terms. What like terms do you see? The cube terms. 7y cubed minus y cubed would be 6y cubed. Next, minus 4y squared. There aren't any other terms there. Next, plus 10. Still don't have any y terms. That's what we've got. Does that make sense? Any questions on that? Okay, again, there's a B in the book as well, and so go through and do that one as well. I'm going to erase what we just did in case, unless someone needs it a little bit longer. No? Okay, because they're going to do all the same steps again. They wrote it, and again, because you're subtracting this from that, you put this one first, and then subtract this one from that, okay? The verbiage is important, okay? They put them both in parentheses. This one doesn't help you any. Just going to remove those parentheses. But then you're going to distribute the minus sign across the other. So that would be 7y cubed plus 8. Stays exactly the same. They don't need the parentheses there either. Then they changed the negative sign to a plus sign and negated everything inside the parentheses. That's one way to do it. That's technically perfectly correct. It just seems like to me it's another step of doing something that really isn't necessary. But if you like to do it that way, please do. This is Tiana, right? Okay. And this is Greg Joy. Anyone else come in such a call? Okay? All right. So what they've done is change the subtraction key sign to a positive, but then negated everything inside. Okay? So it'll be a 7. Okay? They're going to draw the error and show you where they did it. Okay? And then they're going to combine like terms, a 7y cubed minus y cubed. That'll give you 6y cubed. Very good. Then the minus 4y squared is the only y squared term they have, so write that down. There aren't any y terms, so you go on to your constant terms. Plus 8 plus 2 is plus 10. There we have it. Okay? Change the signs to the second polynomial and add. You don't need to do an extra step unless you see it better that way. This is on the bottom of page 853. However, this one's not there, but one very similar to it is there. This is the slideshow. Okay? And that's your answer. So I bet you they're going to put a block around it. How nice of them. Okay. Any questions? You see? Understand? Okay. Watch the wording. If you're subtracting something from something, it means you start with the second something because that's what you're subtracting from, and then do the minus sign after the first something. Okay. That's what you're subtracting. All right. There is not a 6C. And by the way, there are the additional examples in the margin, and they have the answers given there. So please pay attention to those and do those as well. Moving on to example 7. Okay? Your book calls them subtracting vertically. This calls it subtracting by columns. Okay? Doesn't matter how you do it, just do it. Okay? Now again, there's lots of ways to approach this. If I were doing it, okay, I would go on and take care of my signs as I went and make it an addition problem. However, if you want to carry it through the subtraction way, you certainly can too. But you see, this is obviously the one that stays alone, the 4g to the fourth plus 6g cubed minus g minus 5. You're subtracting from that a negative 6g fourth. Well, what's that the same as? Minus a minus is plus 6g to the fourth. So write that under the g fourth term. Okay, then you have a minus a 2g cubed. So what does that become? Minus 2g cubed. They don't have a squared term here or there. If they did, you would have to insert that between the cubed and the linear. They don't have one, so we just do minus a minus 4 is a plus 4g, and minus a positive 3 is a minus 3. Now that you've taken care of the signs, you're just adding. You're not having to worry about subtraction anymore. So what do these become? 10g to the fourth plus 4g cubed plus 3g minus 8. Very good. Okay? Now, I see no advantage in vertical versus horizontal, columns versus, and what did they say the other one was? Well, vertically or columns, horizontally or whatever. Whatever you see best. Just don't get yourself confused by when you negate here and make it a plus, you've already taken care of the subtraction, now you're adding. Okay? I bet you, I don't know how they're going to do it. We'll see how they do it. If their way of doing it, you understand better than what I just said, go for it. Watch. Hopefully we'll get the same answer. You ready to see? That's the thing. You can do these several ways, and I can't teach you every way. The book can't teach you every way. You do what makes the most sense for you. So let's see how they're going to do it. Arrange like terms in columns. That's what we did. So, all right. Now this kind of drives me nuts. I was afraid they were going to do this. Okay? They arranged them in columns, but they didn't put the sign in front of them. If I saw that, I would think that was an addition problem. It's not. We know it's not. It's a subtraction. So they should have at least put the minus here and then put that in parentheses or something. To write it like this, to me, makes it more confusing. Okay? But it is a subtraction problem, but they don't have anything there indicating it's a subtraction. So the next step is change all the signs in the second row. Yeah, I would have done that if you'd have put a minus sign in front of it. So that's why I don't like this method too much. Okay? So that becomes 4g to the fourth plus 6g cubed minus g minus 5. That was the minuend. And then the subtrahend, you're changing the signs to add, which is exactly what we did, but we did it straight from here. And changed the signs, distributed that across, and wrote them here. And this is what we got. Plus 6 4g, 6g to the fourth, minus 2g cubed, plus 4g, minus 3. Exactly what we did without the step in here, because that step to me is confusing unless you put the minus sign here. If you put the minus sign, it's perfectly fine. Without it, to me, that's confusing. Okay? So you do it whatever you see best, just get it right. Okay? And when you combine these terms, for some reason they're not combining yet. Oh, they're starting from the right. It doesn't matter, but it can. That's a negative 8, a positive 3g, a plus 4g cubed, and a 10g to the fourth, and that's your answer. And that's exactly what we got, right? When we did it. Okay. So, folks, do what makes sense to you. Make sure whatever method you use, you can account for every step, and you know you're doing it right. Okay? Any questions? That's example 7. Here's example 8. Okay? This is a multiple. Okay? What you're doing here is starting with a polynomial, subtracting a polynomial from it, then adding a polynomial to it. Now, what do you notice about these polynomials? Written in ascending order of the terms, not standard form, descending. But guess what? As long as you're consistent, it's okay. Okay? All you're going to do is combine like terms anyway. So what we do here is write this one down. You don't really even need the parentheses. But then the subtraction one, what do we do with it? Change all the signs inside. So I would have just left this off and done a minus 6, minus 4m, minus of minuses, plus 7m squared. And then with the plus in front, lose the parentheses. Plus 9 minus m plus 3m squared. Okay? Now what do we do? Combine like terms. What like terms do you see? Frankly, I like to start with the big ones. So what have you got? Okay, you're starting where? Say again? You're starting with the 2, okay, you're going to start with the little ones, okay? That's how they wrote it, so I might as well. Well, I like to start then with the positives. There you 2 and 9 is 11 minus 6 is 5, okay? So that would give us a 5, okay? Now let's do with the m terms. They're all negative. Once you distribute it there, they're all negative. So negative 3, negative 4, that would be negative 7, and another one, negative 8. Okay? Negative 8. Okay? And then, yeah, all your m squareds are positive. So, second? 15, because 7 and 3 is 10, plus 5 is 15, plus 15 m squared. There's your answer. All right, does everybody see that? How you do it? Why you do it? All right, to erase it, because they're going to show what they're going to do, and I think it's going to be the same thing. Okay. Rewrite, changing the subtraction to adding the opposite, which is what we did. Okay. Combine like terms. The 2, negative 6 plus 9, that would be 5. A negative 3, negative 4, negative 5, negative m, that would be a negative 8m. and then a plus 5 plus 7 and plus 3, that's a 15 m squared. There's your answer. They're going to block it in. Good for them. Make sense? Any questions on that? Okay?
And so 3M, 4M, and
Right here?
Wait a minute. Yes.
Okay, a negative 3m. This one became a negative 4m, and this one was plus a negative m. So when you're combining those, keep the m, sort of factor out the m, add the numerator, the coefficients.
So
Minus
negative 3m plus negative 4m plus 1.
A negative 1m,
Yeah,
right.
negative m equals 8.
Negative 8m, right.
I'm
Perfect.
sorry.
Okay?
And then 2, negative 6.
Okay, and if you do it that way, you could do 2 plus a negative 6 is negative 4, plus 9 is negative 4 plus 9.
13.
No, negative 4 plus 9. Okay? You owe me $4, but then you...
5.
Yes, 5.
Yes, so we
Yeah.
subtract. Okay.
Right.
I added it. Okay.
Right,
So
exactly.
negative.
Yeah. Watch those signs. They sneak up and
Yeah,
bite you where you don't like to be bit. Huh?
confusing.
What's that?
It's kind of confusing me because we've added another step to it.
Right.
Okay. Negative 6 plus 9. Subtract.
That's why I like to go on and add the positives. If there were more than one negative, add the negatives and then just do a subtraction. Because if you have different signs, take the difference. Yeah. But you can do it any way you want to. As long as it's right. I don't want any wrong answers. Okay? Okay. Good deal. That was example 8. Here's example 9. Okay? Add or subtract as indicated. Okay? Now this one we have more than one variable. That's what they mean, multivariable polynomials. You have C's and D's. Okay? So add or subtract is indicated. What is indicated to you there? Say again? I can't hear you. Parentheses. You want to remove them? Is that what you're saying? Okay. Let's get rid of them. Okay. 6C minus 2CD plus D, because there's nothing in front, nothing changes there. Plus doesn't change anything inside, so we'll put a 3C plus 9CD minus 4D. And now what? Second? Like terms. And what like terms do you see? 6C and 3C makes 9C. Okay, here you have a minus 2CD, a plus 9CD. We keep the CD. The bigger number is positive, so it's going to be a plus. And how many? You said 7, because negative 2 plus 9 is positive 7. And then finally, minus 3D. Okay, three-dimensional. Okay. Looks like we got a reasonable answer. Ready to go for it? Okay, let me erase my scratch here so that you can see what they write. They first combine. They didn't bother with removing parentheses. They just are combining. 6C plus 3C is 9C. Then minus 2CD plus 9CD is plus 7CD. Finally, yes, plus D minus 4D is minus 3D. And there's your answer. Wish I could make it harder, but I've never figured out a way to do it. Okay? There we go. They're going to put a block around it. Make sense? Any questions? Okay, that's 9A. Let's do 9B. Okay? Add or subtract is indicated. All right. What would you do first?
Distribute the negative across the parentheses for the second row.
Okay, a little louder.
Distribute the negative across the parentheses.
Okay, you're going to distribute the negative through there. So this one will just be 2a squared b minus 4ab plus b squared. And what will the next one be? Negative 5a squared b plus 3ab minus 7b squared. And now what? Combine like terms. What like terms do you see? Yeah, the ab squared terms are like, so what does that give us? Negative 3a squared b. Next, minus ab, because it's minus 4 plus 3 is minus 1, so you can leave off the 1, and minus 6b squared. Pretty negative problem, doesn't it? Okay. All right. Excuse me, I got to sneeze. Sorry. Okay. Poor people listening at home may not have caught that. Okay. All right. Make sense? Any questions? So let's clear it and see what they did. All right. I know what they're doing. I'm guessing what they're going to do. They're going to change that minus to a plus and then negate everything inside the parentheses, which does the same thing we did. It just takes an extra step. So I like the way y'all did it, but if you like this way better, go for it. Oh, they didn't. Look at this. They did it the way we did that time. Good for them. They removed the parentheses here, and then they negated and removed the parentheses here. Minus 5a squared b plus 3ab minus 7b squared. And then combine like terms. Wow! Without even coloring them in, they did it. A 2a squared b minus 5a squared b is minus 3a squared b. Minus 4ab plus 3ab is minus ab. And minus, or b squared minus 7b squared gives you a negative 6b squared. So they're cutting out some of their steps now. Why they put them in the first place, I'm not really sure. But, yeah, this is how it works. Any questions on that? Pretty straightforward, huh? And from my telling, that's the last in the section. So homework exercises here. Let's do a concept check here. Fill in the blank on these first. In the term 7x to the 5th. Got it? I'll back up one. And here's a term 7x to the 5th. Okay? The coefficient is, what's the coefficient? 7's the coefficient, and the exponent is 5, okay? Which makes that a what degree polynomial? Say again? Fifth degree polynomial, and what type of polynomial? Monomial. Very good. Number 2, okay, this is multiple choice. The expression, boy, this is so, y'all even want to do these. The expression, I can't write, 5x cubed minus 4x squared has how many terms? 2. We call it a binomial. Okay, number 3. The degree of the term negative 4x to the 8th is the degree of the term 8. Very good. Number 4, the polynomial 4x squared minus y squared is or is not an example of a trinomial? Not. It's a binomial. Only has two terms. Okay? Number 5, when x squared plus 10 is evaluated for x equal 4, what is the result? A little louder. When x squared plus 10 is evaluated at the value x equal 4, what is the result? 26. You got it. Because 4 squared is 16 plus 10 is 26. Okay? Blank is an example of a monomial with a coefficient of 5. Variable x and degree 9. Okay? You make up a monomial with those characteristics. 5 x. Huh? No, degree is 9. So that's the exponent. The degree is the exponent. Okay. All right, the rest of these, you can do any of the ones 7 through 16. I would definitely do a few. Do any of the ones 17 through 30. And this is on page 855, by the way. And then do some of the ones 31 through 40. Then do some of the ones 41 through 48. And some of the ones 49 through 58. Then do some of the ones between 59 and 70. Okay? Then, pretty little colored blocks here, do some of the ones between 71 and 76. And then any of the ones 77 through 82. A few more colored shapes here. Do either 83 or 84 or both. Okay? Now there's some relating concepts that individual or group work. You can work with these individually or you can get together with somebody and you can do any of the 4, 85 to 88. All right, any questions? All right, we will discard those and move on to 13.2. Any of you ever played cribbage? Cribbage. It's an old board game. You play it with playing cards, but you have a board with pegs and you advance and things like this. My dad was in the Navy and he really liked cribbage, so we learned it when we were young. But we always were counting up the points. 15-2, 15-4, yeah, it's a 13-2. It sounded like a cribbage score, but it's not. Okay, never mind. All right, we will pick up and go from here. Slideshow, current slide. Exponents and polynomials, that's chapter 13. In 13.2, we're going to be looking at the product rule and power rules for exponents. And here are some of the objectives, that's maybe all of them. We'll use exponents. Yes, we've been using exponents before, so we're going to use it a different way. But specifically, we'll be using the product rule for the exponents. And I can remember doing some of these earlier too. We'll use the power rule for exponents. That's a to the m. Then that's raised to the n power. What does that mean? And that's what it tells us it means. We'll use the product of the bases raised to a common power, and we'll find out that's going to be the result. We'll use the quotient of the bases raised to the same power, find out that's the quotient of the powers. And number 6, we'll use combinations of the rules for exponents. And finally, use the rules for exponents in a geometry application. That sounds fun, doesn't it? Okay, let's go with it. So here's example 1. Okay? Now this isn't the same one in the book, but it's very similar. What do we mean by 2 times 2 times 2 times 2 times 2 times 2? If we write that in exponential form, what would that be? Whoops, let me get my pen back. That would be 2 to the 6th power. Like I said before, mathematicians tend to be a little lazy. Rather than having to write out the same power over and over and over again, they just say 2 to the 6th power. It's just a shorthand way of saying exactly what that is. Anyone tell me what that is, by the way? 64, perfect, okay? I don't know how you did it, but when I look at that, I'd say 2 times 2 times 2 is 8 times 8 is 64. Very good, okay. It says and evaluate, so we did evaluate it. The one in the book was a little tougher. It was 3 to the 5th times, and that was a little bit bigger number. But anyway, let me get this out of the way. I thought it might not be, but it is. Since 2 occurs as a factor 6 times, the base is 2, the exponent is 6. 2 to the 6th power. Okay? And the exponential expression 2 to the 6 is read 2 to the 6th power, or simply 2 to the 6th. Okay? They still haven't evaluated it for us. Oh, here it is. 2 to the 6th is 2 times 2 times 2 times 2 times 2 times 2. The base is 2. The exponent or power is 6. That's how many times that base is multiplied by itself. 6 factors of 2. Lots of ways to say this. Are they ever going to evaluate it? Ah, there we go. Is equal to 64. Okay? If you didn't want to do it the way I did before, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Any way you do it, it comes out that, or at least it's better. Okay? Good deal. Any questions? Okay? Here's example 2. Now this doesn't quite look like the one in the text, but let's see. Evaluate. Name the base and the exponent. 2 to the 4th, what's the base? 2, what's the exponent? 4, what's the evaluation? 16. Good deal. See what they got? Whoa! Wow. Thought they were going to take up more room than that. Okay, that's 16. The base was 2, the exponent 4. Okay, the B. What in the world does that mean? Negative 2 to the 4th. Second? Not really. If that was negative 2 in parentheses to the 4th, yes, it would be 16. But it's negative 2 to the 4th. And when Aunt Sally did something wrong, what do? Please excuse her. Okay? And the exponent, E, comes before Aunt Sally. Please excuse my dear Aunt Sally. So you exponentiate before you negate. So that's the same. Say again?
We'll put a 1. Do a 1 times 2 plus 2 times 2.
You could do that, but the better idea is just to do that first, that's 16, then you negate that. Okay? So, unless they've written it wrong, this is what you should have. That's exactly what they did. Put a negative 1 in front. Okay? And that would be negative 1 times 2 to the 4th, which is negative 16. The base there was still 2, the exponent was still 4, it's just you had a coefficient of negative 1. Okay? So it is looking a lot like the one in the text. They just don't have the box drawn around it. How about that one? Negative 2 to the 4th power. What would that be? Think I heard someone say it? That's going to be 16. Why is that? It's what? Yeah, oh, you got parentheses on it. But the more important thing is you have a negative base being raised an even number of times. If that would have been a 5 there, your answer would have been negative. Because negative 2 times negative 2 is positive. Negative 2 times negative 2 is positive. Positive times positive is positive. Then when you multiply that by negative 2, it goes negative. So, if you have a negative base, even exponent, your answer is always going to be positive. If you have a negative base odd exponent, the answer is always going to be negative. If you have a positive base, no matter what your exponent is, it's going to be positive. Right? So here, let me erase mine because they're going right on top of it. I don't like for them to do that, so I'm going to erase mine first. And that's going to be negative 2 times negative 2 times negative 2 times negative 2. And that's going to be a positive 16 because negative times negative is positive. Negative times negative is positive. Positive times positive is positive. And those are all 2, so it's 16. Your base is negative 2. Your exponent is still 4. Does that make sense? And again, the one in the text is a little bit bigger numbers. 5 was your base, so it makes for a lot bigger numbers. Okay. All right. Let's move on to objective 2. Nope, this is the caution. Caution. When you have minus a to the n, your base is the a, the exponent's n, the minus is your coefficient. And here's the one they had in the text, except they didn't have it in the text, but something similar. Okay? That would be minus 5 squared. What's 5 squared? 25, and negate that, you get minus 25. Or put the minus up front, then in parentheses, multiply. Negative a to the nth is negative a times negative a times n times. So the base would be negative a, the exponent is still n. So for instance, if a were 5, then negative 5 squared would be negative 5 times negative 5, which is negative times negative is positive 25. So in summary, negative a to the n and negative a to the n are not necessarily the same. Occasionally they'll be the same, but other times they may not. Okay? So be careful with them. Very careful. Please excuse my dear Aunt Sally. Whatever she did, you know, she'll keep you out of problems usually pretty well. All right, so here is the product rule for exponents. Okay? In the book, let's see, where is it? I don't see that they explicitly said it, at least on this page. It's coming up on the next page. Okay? For any positive integers, m and n, positive integers, m and n, if you have the same base raised to different powers, but you're multiplying those together, what you do is keep the base, add the exponents. Okay? Now, why? I think we've done this one before too. Okay? If this was 5 to the third power, that means 5 times 5 times 5. And you multiply that by 5, same base, different exponent, 4. 5 to the fourth is 5 times 5 times 5 times 5. And if you multiply those together, you have the same base, 5, raised to the 1, 2, 3, 4, 5, 6, 7 power, which is 3 plus 4, 5 to the 7. Okay? Now that's one big enough, I'm not about to do that one in my head. Okay? But calculators will. So you certainly can do that. This isn't particularly easy to do anyway, 5 times 5 is 25. Times 5 is 125. So that's 125 times, well, 125 times 5 again would be, yeah, 125 times another 5 is 625. So 625 times 125. Whatever that turns out to be. Pull out your calculator and see. Okay? They didn't bother to do it either. Okay? They did examples with 2s and 6s, and they just left it in that form. 5 to the 7th. They did theirs 6 to the 7th, but they had different numbers of the exponents. All right, so using the product rule for exponents, do not multiply the bases. Keep the base, add the exponents. Okay? 5, I wouldn't even write this down because this is planting an idea in your head, doesn't need to be there. 5 to the 3rd times 5 to the 4th. Keep the base, 5, add the exponent 7. Do not multiply the bases. So much, incredibly larger number. You're not doing that. It's 5 times 5 times 5, times 5 times 5 times 5 times 5 times 5. No 25s in there at all. Okay? So no, that's totally wrong to do it that way. So I don't think I would have even written it. Okay? So example 3. All right, this is from the slide set. The ones from the book are given in the book, so you can read through those. You tell me what to do for this one. What would that be? 7 to the 13th power. That's all, folks. And they're not even asking us to evaluate it. Thank you very much. I would hate to have to evaluate that one. Okay? Enormous number. Okay? 7 to the 5 plus 8 power, 7 to the 13. Good for them. Okay? How about that one? Negative 2 to the 9th power. And again, I don't want to do that one either. But you tell me, is the answer going to be positive or negative? Negative, because that's a negative base, but with an odd exponent. So that will be negative. Okay? So, see what they did? Negative 2 raised to the 4 plus 5, which is negative 2 to the 9th. Good for them. C, y times y to the 5th. What would that be? Y to the 6. Why? Because if you don't see an exponent, you understand it to be a 1. Just like if you don't see a coefficient, you understand that to be a 1. So this is y to the 1st times y to the 5th. Keep the base y, add the exponents. 1 plus 5 is 6. Okay? Very good. Y'all are sharp. That's y to the 1 times y to the 5th. That's y to the 1 plus 5, which is y to the 6th. Does everybody see that? Sorry. Sorry about the yawning, folks. I had a treatment on Friday, and Saturday I felt pretty good. Sunday I was dragging, and today I am drug. It's just, I feel, and then I don't think springing ahead did me any good either, but boy, do I feel rotten today. But we'll get over that, won't we? Okay. So there's 3A, B, C. In the book, we have a D, E, and F. Let's see if they do here. Yeah, here's a D. Use the product rule for exponents to simplify, if possible. What would this be? N to the 6. Keep the base, add the exponents. Very good. N to the 2 plus 4 is n to the 6. Good for them. E, 3 squared times 2 squared.
36.
Say again?
36. They're not the same.
What's that?
36. They're not the same.
Okay, they're not the same. He went on to multiply them. 3 squared is 9, times 2 squared is 4, and that would be 36. Now here's something you can do. Now they haven't told you can do it yet, but you can. Since it's the same exponent, you can multiply these two together. 6 squared is 36. What's that? Well, if these exponents were different, don't even try. But this is 3 squared times 2 squared, so it's 3 times 2 squared. We're going to get that rule in a minute, but that is another way to do it. Okay? And that product rule does not apply because the bases are different. Okay? They just multiply them together. 9 times 4 is 36. And let's see about F. What about this one? Say again? Okay. This is not multiplication. This is addition. There aren't any rules for addition. It's only the product rule. Product rule doesn't apply to addition. Duh. Okay? So this would be, what's 2 cubed? 8 plus 2 squared? 4. 8 plus 4 is 12. There's no shortcut. There's no rule for addition of this. You just raise them to the power, add them together. Okay? That's all, folks. Okay? Product rule does not apply because it's a sum, not a product. However, that would be 2 cubed is 8, 2 squared is 4, and 8 plus 4 is 12. All right, there was our 6 examples there. Let's move on. Any questions? By the way, again, let me remind you, there's all these marginal examples as well. Do those before you even try homework exercises, because these answers are right here on the page. Make sure you understand it before you proceed. Okay? Here's example 4. Multiply 5y cubed times 4y to the 6th. Okay? How would we do that? Say again?
5 times 4.
5 times 4 is 20.
And then keep the bases.
Then your y's are same bases,
And then add the
which gives you y to the 9. That's all you can do. We don't know the value for y. We can't evaluate it. I'm not really wanting to evaluate it because to the 9th power, unless it's a y of 1, which would be really simple, or 0, which would be meaningless, I don't even want to try it. 2 wouldn't be awful, but it still would be pretty bad. But that's what you do. Because, what does this mean? It means 5 times y times y times y times 4 times y times y times y times y, and that would be 5 times 4. Pull that out. 20 times y with 3 factors of y, 6 factors of y. That's 9 factors of y. So 20y to the 9. Make sense? Okay. Let's see how they do. Ooh. When I think they're going to write long ways, they write on top of me. Why is it doing this? Okay. Oh, that's because I was on the wrong icon. There we go. Okay. It's 5 times 4. Multiply the numbers together, then multiply the variables. And that's what we were doing before. Anytime the same base, different exponents, keep the base y and the exponents. Okay. Now, I don't know if this is helpful or not, but this is how I kind of look at it. If you go back to grammar school, okay, first thing you learned was addition and then subtraction. And let's call that the first level of mathematical operations. And then we took it up a notch, Emil, okay, and we did multiplication and division. That's the next level up. And then later we did exponents. And that comes with roots, but we aren't doing roots now. That's the next level up. Okay? Now, when you're multiplying same bases, multiplying, that's that middle level, the exponents drop down a level, add the exponents. Okay? When you're raising same base to powers, that's raising a power to a power, drop down, and you multiply the exponents. We haven't gotten there yet, but you see, with the exponents, you step down one level from what your original operation was. Okay? I don't know if that's helpful or not, but sometimes I think of that. Now, why can we do this? Because the order doesn't matter which you multiply. That means you can commute the 5 and the 4 together, and then associate, you multiply 5 times 4, and then the y's together, and that's associative property. And then from there on, we already know how to do those. Okay? So there's example 4. Okay? 20y to the 3 plus 6, 20y to the 9th. Boy, they take a lot of steps to do it. But if you can skip a few, fine. If not, take them out as many steps as you need to see and know that you're doing it right. Okay? Any questions? That's example 4. Okay, caution. Okay, they like their cautions, don't they? Be sure you understand the difference between adding and multiplying exponential expressions. This is what? How do you do that? Yes, you combine like terms. Factor out the k squared, 7 plus 3 is 10. So that's combining like terms. That's adding. This one, say again? I can't hear. 21. K to the 4th power. 21k to the 4th. Perfect. Okay? When you're adding, you've got to have the same terms there. Just like when you're adding fractions, you've got to have the same denominators, right? Okay? When you're multiplying fractions, you don't. You just multiply. Well, same thing here. When you're adding, you've got to have exactly the same terms or you can't add them. Multiplying, yeah, you can have k2 here, k17 there. That's all right. Still multiply. Okay? Now, here's the one I was just referring to. When you have a power raised to a power, I don't know, there's an old song. Goodness, I don't remember now. Coming through the rye. I can't remember. Okay. A to the m raised to the n. Okay? Now, that's what I was talking about before. Here we're raising a power to a power. And since it's the powers, same base, step down and multiply the exponents. A to the m, raised to the n, a to the mn. Now here's why. Give me a number for m. Any number. Make up a number. Say again? 4, you said? Okay. So m is 4, and what's n? 7. Thank you very much. Okay? All right. Now what that would be a times a times a times a, right? That's a to the 4th. See why I appreciate you so much? Times a times a times a times a. That's twice. Times a times a times a times a. 3 times. Times, thank you very much. A times a times a times a. 4 times a times a times a times a. I'm liking you less and less. Okay, times a times a times a times a. 1, 2, 3, 4, 5, 6 times a times a times a times a. Right? A to the 4th raised 7 times. So you have this factor of a to the 4th as a factor 7 times. How many a's do you have there? 28. 4 times 7 is 28. That's why it works. Right? So when you're raising a power to a power, multiply the exponents. One level down. Powers up here, multiplications here, additions here. Okay. So for any positive integers, m and n, a to the m raised to the n is a to the m times n. Mn means multiply. Raise a power to a power by multiplying the exponents. So what would this one be? 4 cubed squared is 4 to the 6th power. Perfect. Everybody see that? They were much nicer than you were. No. All right. All right. That was the exponential rule, I guess you call it. That's power rule for A for exponents. That's sort of the middle of page 861. So now we're ready for example 5A. Use the power rule for exponents. Why they do power rule A for exponents? Oh yeah, I guess they're going to do something else and they'll call it power rule B, okay? What would that be? Anybody? 3 to the 10th power. Perfect. Okay? Which, by the way, if you were doing it this way, that would be 9 to the 5th power. If you have a calculator, want to plug those in and see 3 to the 5th, if that's the same as 3 to the 10th, same as 9 to the 5th, you'll see they're exactly the same. Okay? They wanted you to do it this way. You did it right. Okay? That's 3 to the 2 times 5, which is 3 to the 10th. Yes. Okay? The B, let me get my scratch out of the way. What would this one be? Oops, let me do it down here. Help me, help me. 4 to the 48. Because it's raising an exponent to an exponent multiplies the exponent. 4 to the 48. If this were 4 to the 8 times 4 to the 6, that would have been 4 to the 14. Multiplying adds the exponents. Okay? Now, at some point, folks, I don't know how big and powerful your calculators are, you're going to get so you can't even evaluate these things. Raising 4 to the 48th power is going to be an enormous number. Okay? I'm not sure the last little old calculator I had would have handled that. It seems like it would go up to about the 90-something power, but still huge, huge numbers. Okay? That's the B part. That's 4 to the 8 times 6, which is 4 to the 48th. Very good. Okay? Now let's see about C. N to the 7th raised to the 3rd power would be, boy, that's as bad as you, sorry, what was that? N to the 21st power. Perfect. Okay? N to the 7th times 3, which is be n to the 21. Do they have a D here? Yes, they do, and I won't even have to erase. What would that be? What would that be? 2 to the 40th. You're right, and I'll tell you, another, even though it's not nearly as big as 4, and of course not as big as 48 either, still a huge, huge, huge number. Okay? 2 to the 5 times 8 is 2 to the 40th. Okay? Just to give you an idea of how big these numbers get. Are y'all familiar with the game of chess? Played on a 8x8 board, and there are 16 players of 16 pieces for each side. Okay, and evidently this game was developed by a Indian, as in South Asian Indian mathematician. And it got to being distributed around. And this Maharaji, who was ruler over this certain area of India, he loved this game. I mean, he was just enthralled by this game. He said, "Who invented this? Bring him to me. I want to reward him. This is the best thing since sliced bread." And they didn't even eat sliced bread. No, yeah. Anyway, so they went out and found this little meek-mouthed mathematician. You know how we are, and brought him in and said, "Here is the man." He said, "Ask me anything up to half my kingdom. I'll give it to you. I love this game." "Oh, such the fact that you appreciate it. Oh, that's more than enough reward for me." No. I really want to reward you. Ask for anything." And he said, "Take a single grain of rice and put it on the first square. Okay? And then every subsequent square, double the number of grains of rice." He said, "Hey, I meant to give you something great. That's just going to be piddling little rice grains. Who cares?" No, that's enough. That's enough. So he did. And the first square was 1 grain of rice. Second square, 2 grains. Third square, 4 grains. Next square, 8 grains. 16, 32. Got across the first row, you still had just a handful of rice. Okay? But every square you doubled. Before he got to half the board, he would have, I think, emptied every granary in his kingdom. Okay? Before he got to the entire board, it would have been more grains of rice than have ever been grown on the planet, at least up to that time. Maybe we've grown more now. I mean, exponential growth is really, really big. Really, really fast. Try it sometime. Do a 8x8 matrix, 64 squares. Write 1, 2, 4, 6, 8, and double every one, and see how soon the numbers get out of hand. I mean, completely out of hand. All right, that was D. Okay. Example 5. See, the book had only 3 there. We did 4. Good for us. Okay. There also, do the examples in the book and the sidebars that we have there too in the gray margins. All right. Now here is another rule. This is power rule B. Now I know what they're talking about. I thought that was probably it. What if you have a product as a base raised to a power? So this is another power rule for exponents, but now it's a power of products. Okay? So this is AB raised to the nth power. Give me a value for M.
2.
2, I like that one. Okay. Much better. No. Okay. So that would be AB squared. Well, what is AB squared? It's AB times AB, right? Which is A squared, B squared. Yeah, A times A times B times B. Yeah, that fits. And you can use as big or as small M as you want, and it works. For any positive integer M, AB to the nth is the same as A to the nth, B to the nth. Power. You raise a product to a power by raising each factor to the power. So, what would 5h cubed be? Okay, 5 cubed times h cubed. Anyone know what 5 cubed is? 125, perfect. 125 h cubed. That's exactly right. 5 cubed times h cubed. Okay, very good. Yes.
Is there anything we can study that's going to be related to the test in the book?
Okay. I think I told y'all last time, or I think it was, at the end of the chapter, beginning on page 841, they have something called a summary, okay? And that has, in section by section, 12.1, 12.2, and stuff like this. They have key terms, your word power, they have concepts, a quick review there. They have some of the key formulas and equations. That would be fine. And then after they are through with that, on page 844, they have some review exercises, which are, again, very similar to ones you had done before, but this time it's just shortened. And they have it 12.1, 12.2, 12.3, 12.1 through 3, 12.4, 12.5. And remember, we didn't do 12.5, so you don't have to do on the other things. On the summary on page 843 at the bottom where they have 12.5, just go through 12.4, okay? And again, here on the review exercises, only do 12.1 through 12.4. Don't do 12.5. We didn't do those, okay? Then there's some mixed review exercises. As long as they don't have the directional inequalities in them, you can do those too. But then there's a Chapter 12 test. And I'm pretty sure this has the answers in the back.
Is it chapter 11?
Oh, I'm sorry. Goodness gracious. Same thing I'm saying. Yeah, I've just turned over. Chapter 11, let me give you the page numbers for that. Chapter 11 summary is on page 786. The key terms, symbols, your word power, which a quick review, which has a lot of the rules. And again, we did 11.1 through 11.4. We didn't do graphing linear inequalities. Okay? And then
The review exercises is on page
790. Okay? And it'll be 790, 791, going down through 47. 48 and on is 11.5. You don't need to do that. There are some mixed review exercises. You could do those too. Just don't do any of them that have the directional inequalities. Okay? Which I don't really see. Yeah, there are some. 64 and 65, you don't need to do those. Okay? Then there's a Chapter 11 test on page 795. It has several really good problems. Just go down to through 17. You can ignore 18 and 19, but then I think you can do 20 through 24. Okay, sorry. Yeah, those are the ones at the end. Okay, are we just about out of time? Oh, how sad. Okay, let me give you a few more homework exercises here. What we got to was the second power rule, but we didn't. We're going to start next time. Well, we're going to have a test next time, but when we come back, we'll begin at example 6. Okay? So come prepared for the test next time. Now, remind me, let's see. I don't think I let y'all have formula and equation sheets on the other test, did I? No, yeah. Just come ready to take the test. And if you get your quizzes in to me, I can get them graded beforehand. So you get them to me today, tomorrow, or early Wednesday morning. Good deal, thank you. And remember, Mondays, Wednesdays now, I've got to head to the Birmingham campus to teach a class there. So if I leave before you turn something in, just slide it under my door. I'll pick it up tomorrow. All right, take care. All right. Lots of work over the weekend, wasn't it? Okay.